Okay, before we get going though, can you
Yes.
briefly let us know what you want to talk about and why?
So we had a similar chat, like a big birthday celebration, 5 years ago, 25th birthday. So I thought, why don't we just look back at what we've done since then? So what have we done in the last 5 years? And so just kind of take a little look over the past. Then I thought I would look at what we're shipping in JDK 25. I thought I would talk a little bit about flexible constructors because I think it's kind of cool. And then I'll of course tease you a little bit about what might be coming in the future.
Ooh, that last part is always the one that draws me in the most. Okay, I'm gonna let you get to it, Kevin. Have fun.
So thanks, Nikolai. And as I said, I thought today we'd just take a quick look at what we've been doing since the last big birthday, which was the 25th. So here's the timeline since May 2020 that lists just the language JEPs. Of course, that's only a fraction of all the amazing JEPs that we shipped, but these are the language ones. And so if you let me include JDK 25, and it's not quite out yet, but it's getting there, that's 11 releases. And you can see that we've been following the new tradition of previewing language features so people can try the feature out and give us their experience and feedback. And some features have had a couple of previews. One, in fact, only had one. Some have had more. But in total, we've finalized 10 new language features in 5 years, which I think is pretty good going. So, you asked earlier, Nikolai, isn't Java dead? There's a counterpoint to that thought. Um, and you can see that some of these features are like standalone, like text blocks, but others form part of a larger sort of feature arc. For example, we mentioned that there are two JEPs in 25, the compact source files and the module import declarations. They're kind of part of an on-ramp feature arc. Another story arc is the one that we call data-oriented programming, and that's these 6 JEPs that I've circled here in the grid. So let's just take a quick recap on data-oriented programming. So this is a feature arc that concerns better support for plain old data in Java. So why? Well, object-oriented programming has proved to be a perfect fit for modeling complex entities and processes. And that's why kind of object-oriented programming has come to dominate sort of big enterprise software. But I think it's fair to say, if we admit to it, it traditionally has not been so great at modeling plain old data. And more recently, there's been a shift in software architecture towards applications built as smaller services that consume and emit data. And that data is often untyped plain old data. So kind of think JSON. Now, that's kind of bad for object-oriented programming and the languages, object-oriented languages, because now the focus of those applications is on areas that we're not so good at. So that's the motivation. So what are we going to do about it? So the answer, or at least our answer, comes from functional programming, actually from work on the semantics of functional programming. And this work suggests that the plain old data that we're interested in are actually values of what is called algebraic data types. That's kind of a very fancy name, but algebraic data types are a very simple concept. And they're data types that can be built using products and sums. And two features that we've added in this feature arc that I showed you are records and sealed classes. So records are in fact a product type. So for example, a point record is an integer and another integer. So the and means a product. And it's a nominal product type because all types in Java like to have names. So record point, the name is point, right? So a colored point, another record, is an integer and a color. So 3 things producted together. Sealed classes, on the other hand, are nominal sum types, if you look at them. So for example, if we had a sealed interface shape that had 2 permitted implementations, square and circle, so therefore a shape is either a square or a circle. So the or is the sum part. And again, the nominal sum type has a name, shape in this case. So the idea, the trick of data-oriented programming is firstly to use records and sealed classes to model the data. So we're essentially modeling it as algebraic data types. And then we use pattern matching to process this data. And these algebraic data types are everywhere. So here you are, humbly looking at the JSON webpage. There's the spec. And you see this very nice picture explaining what a JSON value is. And the moment you see this, assuming you understand what this railroad diagram is saying, of course, you want to fire up your favorite IDE and write this in Java, right? Because you look at this diagram and go and say, a JSON value can be a string, a number, an object, or an array, or a Boolean, or a null. Okay, all those ors between all those words. Sealed interface. That's a sealed interface JSON. And then all the permitted implementations of that sealed interface, you can now represent as records. So for example, a JSON string is a record with a string component. A JSON array is a record type with a list of JSON value component. Now, the important thing to notice here is the payload, the components, are all Java data types. So a JSON array has a Java list, or a JSON object we model using a Java map. And that means that when you are playing with the components, you're getting hold of the payload and looking at it, we can use all the APIs, all the beautiful support that we have for these data types in Java. So let's look at a simple example of programming with these JSON values. So here we have a JSON value J, and we want to see, is it actually a JSON object? And of course, that will be a map. And in that map, is there a key value pair? So is there a map from a key that is the string name, and does it map to a JSON value that actually turns out to be a JSON string? Is there also a map from the key age to the value that is actually not just a JSON value, but actually a JSON number? And is there a map from city to another JSON string? And if it is, I'd like to have that string, the integer and the string, Java string and integer, to play around with. And now with the beauty of sort of pattern matching, we've got record patterns here, we've got a little API call in the middle, we can now express that quite complicated query. And notice I'm saying nothing about null here. I don't need to. It's all dealt with by pattern matching. I've got it all down to one expression, and I defy any of you who've written anything using DOM objects to do it more clearly than this. So the sort of programming you have with DOMs is kind of like accidental complexity, and here we have the essential complexity. Now you might say, oh, come on, Gavin, this is all, all these examples you show me are so simple. Nothing's this simple in the real world. So I hope you all noticed, but maybe some of you didn't. There was a very interesting announcement last week, exactly a week ago, from my colleague Paul Sandoz, who proposed, as mentioned by Nikolai earlier, a JSON API for Java to be put in the JDK. And you think, oh, that's fantastic. Of course, many of us have wanted that for a long time. And you just scroll down a little bit in his message and you see that Paul says algebraic data types. He talks about sums and products, right? So actually, our library is going to be structured very similarly to the example that I showed you before. It's done slightly differently, but hopefully you'll get the same pattern matching experience. Okay, but don't let me get sidelined by that because I can get very excited about these things. So let's go back to the timeline. So enough about the past, let's move to the present, or just slightly in the future. So JDK 25. So I know Heather and Nikolai spoke a little bit about the about on-ramp, about making things easier for beginners. So I'm going to talk about the third JEP that we are shipping here, which is a JEP called Flexible Constructor Bodies. Now, JEP 5.13 is actually a complete reimagining of the role of constructors and object initialization. You might have thought there was nothing left to be said there, but I'm going to take you on a little walk on and show you a little story, show you that there is actually more to consider here. So what's going on with, let's do a little bit of revisions, right? So the constructors of a class are responsible for creating the valid instances of the class. Okay, I think we all agree on that. And with subclassing, things get more complicated, right? So for example, consider a person class with an employee subclass, right? So when we create an instance of the employee, we're going to expect the two constructors, the person constructor and the employee constructor, they're going to work together to construct a valid instance of employee. So we would expect that the employee constructor would be responsible for the fields declared in the employee class, and the person constructor would be responsible for the fields declared in the person class. Now, we do realize, of course, that the code in the employee constructor can refer to the fields declared in the person class. So we better make sure that's only going to be sensible, i.e. safe, if the so it's only going to be safe for the employee constructor to access those fields after the person constructor has finished its works assigning the values to them. So that's a pretty obvious thing. I don't think anyone would want a world where that wasn't true. So let's give that property a very fancy name, because that's my sort of style. So let's call this an integrity principle, right? So in other words, class constructors kind of get the first responsibility for assigning values to their own fields. Okay. So Java provides guarantee using a very simple notion, which is to require that constructors run from the top down. And it does this in a very simple way. It does it by actually constraining the constructor bodies. So in particular, it says, if you invoke a constructor in your constructor body, it must be right at the top. It must be the first thing that appears in the body. If you don't invoke a constructor, the compiler will actually insert a constructor invocation for you at the very top of your constructor body. So you can't get away from it. The very first thing that's going to happen in your constructor is an invocation of another constructor. So what's the effect of this? So let's consider this crazy hierarchy of 26 classes A to Z that extend each other. And let's imagine that we want to create a new instance of the Z class. So we do new Z. What's actually going to happen? Well, we're going to run the constructor body for Z. The very first thing that does is call the superconstructor. So that means we're going to start running the constructor body for Y. The very first thing that does is call the superconstructor, and that's going to go all the way up to class A. The very first thing class A does is called the superconstructor, which is object. Object is a special class. So now we finally get to execute the constructor body of the class object. Now it returns, and now we get to run the constructor body for class A, then for class B, all the way down to class Y, and then finally the constructor body for class Z. So that's why it's called top down, right? So you ask for a class, but we end up for an instance of a class, but you end up executing all the constructor bodies from sort of object all the way down to that class, down the inheritance hierarchy. So that's great, but, and I suspect you're all aware of this strategy of requiring the constructor invocation to be the very first thing, so we get that top-down behavior, is quite restrictive. So let's go back to our person employee. Let's imagine person has an age, and its constructor, the person constructor, does a quick check to make sure you haven't given it a negative age. Now, in the employee constructor, we get past an age, and employees have this extra domain constraint, which is that they don't allow the age to be under 18 and they don't allow the age to be more than 67. But there's no way to get around the fact that the very first thing you have to do is call the constructor for the person. So, I mean, here it's not such a big deal, but you can imagine examples where this is a real pain because you're going to do potentially a lot of unnecessary work. We already know when we get the age argument that perhaps it's illegal. We don't need to call the person constructor. But no, you can't do that. You have to do your validity check after you've called the superconstructor, which of course could have chained up and called all sorts of other superconstructors as well. So yeah, that's a bit of a pain. I'm sure some of you are clever hackers, so there is a clever hackery way around this. You can use the fact that Java lets you do a certain number of things in the argument position of a supercall. So you could call a static method, so you could put that validity check in the static method and you can call it there. There are some restrictions on what you can put in the argument position. So in this particular example, you can kind of get around it. I would refer to that as an inelegant hack. But it kind of gets even more complicated when you have other sorts of constraints. Like if you have a constraint across multiple arguments, then it's really, really hard to do that in an efficient way. And there are a whole number of limitations that make make this, slightly more than a mild irritation in places. But there's actually something else going on here, which is perhaps a little lesser known. So let me show you. Let's go back to our example of person employee, but let's imagine that I'm going to change the person constructor so it logs when you construct a person. It makes a log, it records it in the log. And by recording it in the log, I mean I've written a method called show that prints it to the screen. Okay, so prints the age to the screen. And so if you look at the bottom of the person constructor, we assign the age argument to the age field, and then we call show. Now, of course, we look at the employee class, and then you say, aha, okay, what the show method, I better override it, right? Because the employee now has another field called office ID. So let's print the office ID. So now we look at the employee constructor. So we have to call super first. We do the check to make sure the age wasn't wrong, and then we assign the office ID. Now, what happens if we create a new employee with the age of 42 and with the office ID Camphora? Okay, so what happens is perhaps a little bit unexpected, because we get both the age being printed out and the office being printed out, and moreover, the value for the office is null, which is kind of from nowhere, right? So what's going on here? Well, what's going on is the fact that the employee constructor that you call when you do new employee, the first thing it does is call the person constructor that then invokes the method show. And what the show method is now overridden. So in fact, it will invoke the show method in the employee class. And so what's going on here is that you're actually noticing that very kindly, the JVM has put a default value in the field office ID. The default value for a string type is null. So if you kind of squint at it, what's happened here is that the person class, the superclass, has managed to get its hands on, by printing it to the screen, but you can imagine more dire situations, is managed to get hold of your field before you had the chance to assign any value to it. And I said that was an integrity principle that we'd like to be true. And oh, it's kind of not true. So in other words, the integrity of the employee class being violated. And that's actually nothing to do with it not being final. If you make it final, you get the same behavior. So this is not a new observation. It's well known. It's in fact item 19 of the effective Java book, which says don't call overridable methods in constructors because crazy stuff's going to happen and you won't understand it. But observe, there's nothing in the language to stop you doing it. And there are many hard to find bugs out there in the wild along these lines. So in conclusion, right, we had constructor invocation must come first was a real pain. It limited the sorts of things that we wanted to write. And moreover, we don't seem to have the integrity constraints or principles that we thought we might have. So can we do better? We'd obviously like more expressivity. We'd like to defend our integrity. And of course, we don't want any change to we don't want to have to change the JVM in any way, because that's going to add like a decade to the timeline of this feature. And it turns out that we can reimagine what constructor bodies are, and we can solve these problems. So let's allow statements to appear before a constructor invocation. You remember I said that you could do things in the argument position of a supercall and there were restrictions. So let's just say those statements that appear before the constructor invocation, they have the same sort of restrictions. So we'll call those statements that appear before the constructor invocation the prologue. Then we're going to have the constructor invocation, and then we're going to have the statements that appear after. And obviously that's just any old statements. Now, of course, the prologue, the epilogue could be empty, no problem. Now, if you have that, what happens with that call graph, right, when we had those 26 classes A through Z? So now when you try and create a new Z object, we're going to first execute the prologue of class Z. then we do the supercall. Then we'll execute the prologue of class Y and do the supercall all the way up to class A. So we'll execute the prologue of class A. Then we're going to do the supercall. We'll execute the constructor for object. And now, as we come back down, we will do the epilogue. So the stuff after the constructor invocation in class A, then the stuff after the constructor invocation in class B, and all the way down to class Z. So that's a very nice picture because it's kind of balanced. But let's see it in action, right? You might wonder what I said there were some restrictions on the code that you could write in the prologue. So it's a little bit kind of detailed, but essentially the restriction says, look, you can't use the current object being constructed in the prologue. And that seems reasonable, right? Because I'm still constructing the object. So obviously anything to do with this seems very dodgy because I haven't finished, my superclass hasn't even had a go at initializing fields and so on. So essentially it's code that doesn't involve this. So let's go back to our examples where we thought things weren't as beautiful as we wanted them to be. So here we had the employee constructor that did the validity check on the argument. It had to do it after the super in old Java, but now you can move it into the prologue. You can do it before the super call. So we're happy. One thing that we didn't realize when we started this project, I will freely admit, but it turns out that it's safe not just to restrict using this. You can allow assignment to the fields declared in your class, not reading them, but assignment to them. It turns out that's safe. So if we allow that sort of code in the prologue, we can actually address the integrity problems. So let's look again at our employee constructor that we had this problem with the office ID and so on. So let's look at it. It's got the super call, the validity check on the age, and then it assigns the office ID. Well, of course, we know that we can move the age, the validity check on age, we know we can move that to the prologue. So that's good. But remember, I just said it's okay to write to fields in the prologue too. So that means that this little assignment here, I can move into the prologue. So now we can check the age and assign the office ID field before we do the constructor invocation to super. And that means that when you try and when we create an employee with age 42 and office ID Camfora, you get the answer you would hope for, right? So in other words, the employee constructor can defend its own integrity, and that's great. So that's what I want to say about this feature, but I do want to speak to kind of the community aspect here. You will see if you go to the JEP, this JEP was originated by Archie Cobbs, who is not a member of JPG, nor even an employee of Oracle. Archie is a member of the OpenJDK community. He's a developer, works for another company. He proposed this feature, he built the first prototype, he wrote the first draft JEP, and we then collaborated with him to kind of harden it up, make it enterprise strength, and help him write the specs and so on and so forth. But we're very grateful to him, and I'm certainly very grateful to him for his hard work. And I think everyone in the community should be very happy with his work because he's undoubtedly helped make Java better. And also I think it proves, if anyone doubted it, but here's your proof, that it is possible to make very significant contributions to the Java platform from outside Oracle. Okay, so what's coming in the future? So, predicting the future is kind of a bit of a fool's game, but let me just tell you kind of, since I know what's in the pipeline, let me kind of make some reasonably well-informed predictions about what's coming. So I think there's really sort of three themes that I'm confident to predict. So one is more pattern matching. So you will have seen earlier on, I showed you a record pattern, which was this way of deconstructing a record class instance. So the clue's in the name. The only instances that we can deconstruct with a pattern are instances of record classes. We can do that because record classes are very constrained and the compiler knows what you want. But of course, we would love all classes, so just regular classes, to be able to be deconstructed with pattern matching. So we have a proposal, we have a prototype, we have very well developed ideas about how we can support that going forward. Now, of course, the compiler is not going to be able to know how to deconstruct your objects. So class authors are going to have to write new declarations in their class body to explain how to deconstruct an instance of the class. Now, it sounds scary, but it turns out to be, in practice, not that hard, because, and kind of the clues in the name, deconstruction is kind of like construction going backwards. So constructors typically take arguments and build an instance, and pattern matching and deconstructing it into some components is essentially take the inverse operation, right? It's taking the instance and telling you what the value of the components are. So in our current proposal, the deconstructors, the code inside them that you have to write, looks very much like the constructor code, just with swapping the assignments around. So I think that's going to be relatively easy for developers to get on top of. I think the thing I showed you earlier about the JSON API and being kind of written in a way that will make it amenable to using pattern matching, I think, and certainly when we add pattern matching to other classes, I will expect us to do that in the JDK. And then I think maybe some of the APIs will get tweaked so you can do switches over values of your favorite JDK classes. Second theme. Okay, so you all know about the big earthquake to the Java platform, which is Project Valhalla. And like many earthquakes, there's an associated tidal wave that's going to come and wash over you. And it's the case for Project Valhalla too. So Java developers are going to get features coming from Project Valhalla. The two notable ones are the ability for you to mark a class being a value class, which means that you're a class that doesn't need to use its identity anywhere. And moreover, you are telling the runtime that you want equality of your instances to be based on the values of your fields, not on your object ID, because I just said I was a value and I didn't care about my object ID. Now, the reason why you want to do that, well, one is many classes never use its object ID, and you might really like the ability just to say, I don't want to use the object ID, don't let me do it, and moreover, don't let anyone else rely on it, don't let anyone take a lock on me, etc. But also the runtime, the JIT, can use that information to go, aha, okay, I see you don't use the object ID, I see you're only three things, maybe I can inline them for you. So we're hoping that that will make code kind of compact and faster. So that would be a good thing. The second thing from Valhalla is the ability to mark reference types as never having the value null. Now, this is a very often requested feature, and it exists in other languages that we also know about and like. I think the way we can do it with Valhalla is a little bit different to kind of match the very specific details that we're going for, but you will be able to mark types, I think, with the ability to say either it can't have null or it could have null. And the third thing I'll mention is I often get asked about string templates, which was a feature that we previewed for a few releases, and then we withdrew because it wasn't quite what we wanted. So we have some very cool ideas about that. We have a prototype, very excited about it. It's not quite ready for me to share much, but we are hoping that very soon we'll have something to share with people about kind of a successor to that feature. And in fact, there are many others, some of which are equally as exciting as these ones, but I'm going to keep my powder dry and not talk about them quite yet. But hopefully I'll get a chance to talk about them in the near future. So my time is nearly up. So at that, I'll say thank you and guess happy birthday, Java.